energy the largest. So the mechanical energy of the sled is equal to kinetic energy only, because it doesn't say anything about different height. So speed is going to be greatest at the lowest point. So and oh wait, there is height. I mean, this is referring back to this question. So kinetic energy. So we're looking for when is the kinetic energy the greatest. Find the largest kinetic energy, and that's going to be at point B. Well, that's because that's when all the potential energy has become kinetic energy, and that's when it's the most. So system A has the max energy at point B. Now for system B, that's sled in the earth. So and then this system, we have the acting forces of Fg and what is this? Sled and the earth. Well, now we know that gravity is internal, right? And then Ff, there's no friction. So therefore there is no energy loss. That's because it's including the earth. So that means this is now something that's not accounted for because it includes the earth. So it's not going against the earth. So that means that mechanical energy is conserved and constant everywhere. So that means that system B, that's going to be none because it's going to be constant. So, okay, actually, I just realized I circled the wrong thing I meant to say. Whoa. Oh, okay, wait, I just realized. So this system A is, oh, these are options. So system A, this is going to be point B, and then this is going to be none. So the answer that corresponds to is C. We have point B and none. So that's going to be answer option C. So you're just asking which point is the mechanical energy maximum, and then first before you ask that, you have to ask, is energy conserved for the system? If yes, that means it's either none or constant, and if no, then you look for the max speed or the max height. Okay, that was a lot. So an acrobat is initially hanging from a bar over a platform of negligible mass that is attached to a spring as shown. The acrobat then releases the bar and then falls to the platform. When the acrobat lands on the platform and the acrobat continue moving downward until they momentarily come to rest. When the spring is compressed a maximum distance, consider the system consisting of the acrobat and the spring. Which of the following correctly indicates the moment when the acrobat's spring system has the largest total mechanical energy and provide a valid justification? So when does it have the largest total mechanical energy? So the system, again, our system is the acrobat plus spring, not the earth. And therefore that means that gravitational potential energy, gravitational potential energy is external. Okay, whoa, I'm kind of, UG is external. Okay, so that means that gravity does work on the system because it's external. So now if we track the energy over time, we have immediately after the release. Well, immediately after the release, the spring unstretched. It's unstretched. So that means you have your spring potential energy, U spring is going to equal to 0. And then the acrobat, he has gravitational potential energy. Acrobat has UG, but it's external. So that means, and the mechanical energy of system is small. Okay, but while it's falling, we know that gravity does positive external work, and that means that the mechanical energy of the system, it increases because you're adding energy to the system. Now, at the max spring compression, well, at this point, we have the acrobat and the platform. For a moment, they're momentarily at rest. And then all the energy stored, so, is gonna be spring potential energy. And then at this point, the gravity has done max possible work. So, and this is done max possible work. This is when the system's mechanical energy is the largest. So, immediately after the acrobat releases the bar, because the acrobat is greatest distance above the lowest point, has the greatest point? No, because highest gravitational potential energy is external to the system. Immediately after the acrobat releases the bar, because the spring is at its maximum length. No, because spring length doesn't determine the total energy. When the acrobat and the platform come to rest, because that's when the acrobat has fallen, the maximum amount of and all the work done by the gravity in the acrobat has been converted into potential energy in the spring. Yes. And that's for funsies, let's look at D. When the acrobat and the platform come to rest, because the spring has transferred all of its energy to the acrobat. Well, the spring doesn't transfer energy to the acrobat. It stores it, so no. Alright, that's it. Thanks for watching.